recorded differently after that begin of a transaction than on the end of that transaction. So let's say that I'm about to log on. And I'll take another snapshot. So again, while I click on that snapshot, we have it at a saving state. I can keep moving around in my system. There's not much I can do here, but I can keep moving around in it. As soon as this is done, I'll have a snapshot that I took right before I logged in. I'll have a snapshot that I took after I logged in. And I can roll back to either of those two. And when I click on rollback, I can go back to that exact state of the whole machine, including the instructions, the network connections, the file system, everything. So let's say this is what I've done sometimes. You download this really cool piece of shareware off of the internet and you're not sure that it's going to eat your system or not. Click a snapshot before you run the program. If you suddenly find you have no C drive left, then it was a piece of virus and you know that it is. Click on restore. You're back exactly to where you were before that piece of software did anything to your system. And this is not like Windows rollback where it kind of rolled back and you don't know what it did and what it didn't do. This is exactly to the point, to the instruction that I was executing at the point I clicked that button. Because it's the second state, it's taking a little bit longer because it queued the first one and then it's doing the second one. Yes, sir.
Now, does that just compile everything and save it as a separate file, separate from the virtual machine? So does it take at least double the amount of space?
That's the really crazy part. It only costs the difference. So if you don't make a whole lot of changes, the snapshot will be small. If you make a lot of changes, then as you write new stuff, that new snapshot, your new current image will keep growing. If I roll back and I delete that old snapshot, then it's gone. So as soon as this is done here, this is really handy. You can do this right in the middle of while your program is running. I don't know if I can get into the snapshot tree while I'm in. So basically what you've got is you've got the snapshot tree, and you can click on either of these two snapshots. And if I revert to this one, these two will stay out there, and I can start a new fork of my system. So for example, I have one, count them, one Windows 7 key. I have one, count them, one Windows 7 VMs. I have about 8 different root snapshots. One for each cluster of applications that I want to use, and I don't want them to see each other. So for instance, my banking system doesn't need to see TI's code composer. So those are 2 different snapshots. My Internet Exploiter, let my internet run wild Windows snapshot is completely different from the other 2. A change to one doesn't affect any of the other ones because they are all isolated by the snapshot that you put in. What's really cool and exciting about this is once you have a snapshot the way you like it, you can click on clone and make a whole new virtual machine based on that image at that time. So this snapshotting is really, really, really important. You can also turn on auto snapshot, and so periodically it will click a snapshot while you're working in the background without you even knowing about it. And it'll keep like 2 hours or 3 hours and 3 days and 3 weeks worth of snapshots, and you can roll back anytime. It's kind of like Time Machine, but at the machine level, not at the file system level. So this is really kind of a neat technology. Along with this, and you'll see it up here, is the notion of record. I'm not going to do it because this machine's already stressed out, but if I click on record and I start doing stuff, the snapshot where I clicked record plus the replay button, I can redo a series of actions at the instruction level. Over and over and over and over again. If you ever find a job where you're in quality engineering and you have to redo the same task over and over and over again, you can use this with that replay, and you can replay the exact stream of instructions that caused your device driver to break. And then you can debug it. And in fact, to debug it, they give you an Eclipse plugin. I'm not going to show that either because I'm kind of running out of time. They give you an Eclipse plugin that lets you do debug on your application with the machine running in VMware. You can use replay and snapshots to kind of say, we're going to start from here and reload all of your stuff. that's pretty slick. The Fusion product doesn't have replay or record, just the workstation product. All right, I should be back on the net. And you'll see here, for instance, I have a load of snapshots. I just don't have the Fusion product. It doesn't give you the tree of things. So let's see if we work and roll that. All right, let's just try this real quick. We'll get it. The other possibility is something really bad is going on next door. Because if this isn't responding, I'm surprised if anything is. So another example of using this NAT connection, because I'm sharing my internet connection, I'm also sharing my VPN connection, which just got lost. One more attempt. What I'm hoping to be able to show you, if this doesn't come up, I can at least give you an idea of what we can do. When we create a whole host of virtual machines, we can still do the snapshots, we can save our states, we can move things around just like we do with the other two products. But I have a greater degree over how many resources the virtual machines can use. So I can go in and I can create resource groups. So for example, we have, yeah, something bad is happening. I don't know what. But I can go in and we have the student virtual machine. So we have Cutter, the programming team, and the game development club. I don't want them running something on the VM that's going to interfere with the production servers or the main servers that I run. So they're in a resource group that together they can use at most 8 gigahertz of combined processor power. We have 8 cores over there and 12 gigs of RAM. And altogether they can't use more than 8 gig of RAM. Each machine can have 2. So there's 6 machines they could possibly blow up, but they can't ever use more than what I set them to be. And they're tamped down as far as priority, and they can't use more than X number of gigabytes per second of my disk. And they can't use more than X gigabytes per second of my network connection. I can do the same thing for each machine. So I can go into a virtual machine and say you get this number of processors, this amount of gigahertz, this amount of memory, this amount of network bandwidth, and this amount of disk bandwidth. And VMware will schedule that machine within those confines. So you have very fine-grained control over how you can allocate each of the different machines. You can just dynamically change them. So if I know that Clipper is going to be really, really busy for some student project, I can just go in and pump it up, make it faster. And the next day pump it back down again. Meet me. Without even rebooting Clipper. Clipper doesn't even know until they just got faster. And then it'll go back to being slower again. So it's kind of slick what you can do. And then there's all kinds of resource graphs that plot that over time. So I can go in and I can see how much network traffic, and how much disk traffic, and how much CPU traffic each of the different VMs are using, and how much memory they're using. And I can do all kinds of load balancing. And then we don't have the product, but then they have this thing called vCenter. And vCenter takes all your ESX servers and puts them in one console. And you can say, this machine's running slowly over there, so pick it up and put it on that one. And without the users knowing, all they see is a small pause. The machine is shut down and woken up on the other VM host. And it begins running on that machine. And then you can drag it again, and turn them on, all kinds of crazy stuff. So this virtualization technology is really big business. One of our grad students just got back from the conference. He said there were over 80,000 attendees at the VMworld Conference Center. And their new toy that they're coming out with is something called vCloud, where in addition to your vCenter and you have all your servers, you can lease server space from VMware and drag one of your servers over there. And so if you have like a really big promotion coming up and you know your web servers are going to get hammered, just move them over to the vCenter, let them deal with all of the load. And then the promotion's over, move them back again. And then you can write a script that does it automatically. So if the load hits a certain point, start throwing servers over into the cloud. And then when the load is back into normal, bring it back over, so you're not paying for data traffic that you don't need. And so it's just like you can just just have almost like a power grid of computing. And it's kind of slick how that all works. So these are some of the new trends that are coming down in virtualization. I really encourage you to go in and download the workstation or the Fusion product and start messing around with it, get familiar with it. It's very likely that if you go in a job interview, you're going to be asked about your experience with virtualization, and even if you're going to be a developer at this point. And it would be a good thing to have and say, hey, yes, I know what you're talking about. Any questions?
How does VMware compare to some VirtualBox?
Sun VirtualBox is one of those power virtualization things, as far as I understand it. So Sun is using a limited set of kernels that work within the VirtualBox. And because they're not trying to emulate the instruction stream, the kernels are just cooperating with each other. You get slightly better performance when you're restricted to just the operating system. Now there's another guy there's Zen. There's Zen, which I think is also, there's a version of Zen that's the power virtualization, and now there's a version of Zen for Linux that's free, that lets you do the hardware emulation, but VMware's free, and it's like the Cadillac of products, so might as well just use it. Any other questions? Yes, sir.
The snapshot and retard utility that you mentioned, the virtual machine, is it only applicable in this virtual machine itself, or you can use it in the operating system?
That's only for the hosted operating system. So for the guest operating system. The host machine, you can't do anything about that. It's just VMware is able to replay the instructions that it executed on the guest operating system. Now, the one thing I didn't get a chance to show you is in the VMware workstation product, you can create a new network. So you can create a virtual switch, and you can add different machines to the virtual switch. And you can put 3 or 4 virtual machines up on the switch at a time, and then you can define the switch. So this switch is noisy and it drops packets and it's really slow, like Wi-Fi. And then you can actually benchmark your application across that virtual switch, and then you can change the parameter and run your application and see if it improves or if it degrades. And you can kind of benchmark the performance of your thing and kind of find where the sweet spots are. Your application runs really well, and where it doesn't run at all, and where it kind of runs partially. You can do that all from one machine on your desk. So if you go in, you can mess around with the virtual network configurations. They call it teamed virtual machines, and they all come up with the same virtual switch. Again, it's neat. You can just kind of mess around with it. Like, it's pretty cool. Anything else? All right. What do you guys want to talk about next week? Okay. Google Apps. Kind of cloud computing in general.